Good morning everyone and welcome back to our tutorial on using Sinutrain from Sinu on the 840D. We have already faced more or less all those that are the possible programming options with Sinutrain. Anyone who has followed my tutorial is able to do just about everything. I received a request from some of you that at the time of the request I wasn't using, which is to use DXF files. I tried to accommodate your request by doing some tests. I believe that in turning, starting from a DXF can sometimes be more complex than using conversational programming. That said, knowing all the capabilities of a numerical control can only be beneficial. It also depends on the software you have available, let's say in what will be our technical office. Alright. I saw by fiddling a bit with the Sinumeric allows the option to start from a DXF, such as in both turning and milling operations, as well as allowing flexibility. So, let's do some examples. Let's start with milling, specifically, with pocket milling. I drew this profile that I've roughly dimensioned in the two main sizes. So it's a profile that measures 250 mm in one direction and 224 mm in the other direction. And I thought of, in a case like this actually, starting from CAD from the DXF drawing is indeed more convenient than building the entire profile from scratch. Let's go into our Sinutrain. Let's go to Program Manager and to Parts. Let's start by creating a new program that we'll call DXF, with all the creativity in the world. In Shop Turn, let's define a cylinder with a diameter of 350. Let's accept it and see how we can create a pocket starting from the DXF. So of course we'll go into our milling menu and ask to mill a profile. When I ask him to mill a profile, he says, do you want a new profile or do you want a predefined profile? We're creating a new profile. We have to recreate that it is the usual now option to draw the profile or import from DXF. So let's import from DXF. Let's give it a name. We press Enter. When we press Enter, the machine takes us to what are, let's say, the hard drives that you can access. It could be the USB drive, it could be the system hard drive. In this case, we go where I saved the DXF called profile. Here it is. Now, it's asking me to define a reference point. I can go to choose an element and then define the start or the end, or with the cursor in this case, or I have free input. In this case, for example, it could be x0, y0. Let's give the OK. And we need to go select an element. So by pressing the selection button, you see that it also takes into account the dimensioning lines. I select the element I want to start from, and it asks me, do you want to start from the initial point of the element? From the end point, you see that the blue cursor moves, either from the center of the element. I always recommend starting from the initial point, from the starting point. That said, if there are any specific circles or particular profiles, you can also start from the center of the element. Once I've selected the starting element, I press OK. Right now, it's moving to the element that comes next in the sequence. I accept it. You see that in a very smart way, Numeric allows me to accept all the elements. Perfect. It recognizes that there is a profile. So, if I want to select elements outside of my profile, I have to select them manually. Ideally, though, it's always best to completely clean up the drawing. We have accepted all the elements, so let's go ahead and accept the profile. You finished the acquisition. It asked me, yes, I finished it. Here we go. My profile. Drawn. We accept it, and it brings it into my program. Let's do it again. So let's go ahead and delete this program line. Line of the program. So we want to mill. Let's recap. Milling. New profile import. Let's enable importing from the DXF. Let's give a name to the profile. Let's go to call up the DXF file that defines my profile. Okay. Everyone will have saved it in a part of the PC or CNC that they prefer. So, you go on the profile file of the DXF and you give it the OK. Now we need to establish the point 0.0 in relation to the drawing. So, let's define the reference point. We can use the cursor. We can go to press an element. We can go ahead and type in some coordinates. For simplicity, right now I'm using the cursor. Now I need to select an element. I can select the element either with my cursor or by having it established at CNC. The only thing it will ask me, the CNC, but what is the starting point that we will begin working from? The starting point, element, the end point, the center point. We use the starting point. Then we give it the OK. He moves to the second point that he believes belongs to the profile. Otherwise, I'll have to go to outline them myself, but that's not good. So I'll accept the element until the moment I want to continue the profile. I could also execute a partial profile and then continue it in my drawing. When he closed the profile, I accept it and finish the acquisition. Here, we enter my profile. You see that here. This time I forgot a piece. Unfortunately, I have to start all over again. But since we're here to learn, it definitely doesn't hurt, so let's go for it. New profile, import from DXF. Let's give it a name. Profile. Let's go select the file. DXF profile. Let's define the reference point on which will be calculated all its data. Let's select an element. We accept it. And we go ahead and accept all the other elements. Perfect. You see, you need to close the shape. Don't do like I did earlier. I forgot the last little piece. We accept the profile and finish the acquisition. Now we see that the profile is closed. So we accept it and tell the machine. Good. On this profile, let's do a milling operation. In this particular case, I want to make a pocket, so I'm going to select a cutter. Let's see what we have here. The cutter 10. Cutter 10 is a radius cutter. Perfect. Diameter of 10. Perfect. We give it our OK, the usual cutting data. Our increment. In depth. The depth of our pocket 10 mm, our increase in depth. Let's make it 5. Otherwise, it will take forever. And we choose whether we want to do a roughing, a bottom pass, an edge pass. In this case, we're doing a roughing because we don't have it. And then these are all the various variables that I had already taught you, more or less, in the previous tutorials. So, we accept and simulate. Increase in the plane too large, crest remain. Residue. What does this mean? Let's take a look. Let's cut a bit of the depth. I probably overdid it. A bit with the removals we accept and simulate. I had overdone it a bit with the removal compared to the cutter diameter. And in fact, you see that now. It's starting to work on my profile. Here, I created a profile, randomly without any meaning and without any particular processing. But this has a type of import. The DXF equipment valid for any profile. We want to create. I finished the processing, and as you can see, and that's it. Let's go back to editing. Let's delete everything. Let's go get my cylinder. And let's open our CAD for a moment. Let's close the profile. Do you see this hub? I'll just show it to you for a moment, because it's a real drawing. I've cleaned it up from the dimensions. Okay, I've cleaned it up from the dimensions, and now I want to perform a turning of the external profile. Very simple. Well, after I have properly scaled the blank, which I can imagine by now, you're doing great at this. Let's go to turning car profile. The procedure is the same as what we saw in milling. So, new profile import from XF, we'll call it. Hub. Let's accept it. Let's go look for our file where we previously know we put it. Here it is, hub from XF, and here's our nice drawing. Here too we need to define a reference point. We enable element center and the reference point will always be ours. Zezo. So the face on which we want to build our reference point. In turning, obviously in turning, at least for me as a pure turner, everything is much easier. Now let's select the elements related to our turning. I want to start working from this chamfer. So I'm going to select the chamfer. I give him the OK. And then I will go ahead and accept all the elements up to the point where I want to perform my turning. Perfect. I accept the profile and complete the acquisition. Here's the external turning profile. I accept it. And I won't do anything else like in the previous videos where I drew the profile directly inside Simulatore. A roughing, it should be already done, more or less. I filled it out because last time I used an 80-degree tool, so I'll just go with those parameters. I'm just doing the roughing. I accept and simulate. Too fast, let's slow it down. Check, program, and start. And as you can see, it will be respected. The profile. Created earlier in the CAD at the office. Here it is not. Nothing particularly difficult. After that, you need to adapt a bit to the needs of the various machining processes, everything we've seen in this video, but basically just get started. I would say that working with a DXF using Simulatore is quite easy. I hope what I showed you in this video was of interest to you. If it was, as always, leave a like or just ignore it. Thanks. And until next time, have a great day, everyone.